Hello students, in this video we learn about finding an area between the two curves by using double integration. Given an example, using double integration, find the area between parabolas y square is equal to 4ax and x square equal to 4ay. The area in double integration is given by area is equal to double integration dA, or else you can also write it as it is dy dx or dx dy. Now first thing we need to find the limits of x and y. So here y square is equal to 4ax is a parabola whose axis of the parabola is positive x-axis, and x square is equal to 4ay is the parabola whose axis is positive y-axis. So the region of integration is given by this region. So we have to find the area of this region. So for that, first we will find the point of intersection of these two curves. So by substituting one equation in the another equation, so the point of intersection we can find it by so here let me take from the second equation y is equal to x square by 4a, that I will substitute in the first equation. So that is x square by 4a the whole square is equal to 4ax. So it is x raised to 4 by 64a square is equal to 4ax. X raised to 4 is equal to 64a cube x. It is x raised to 4 minus 64 a cube x is equal to 0. So taking x common, x minus 64 a cube is 0. It is x cube. So x is 0, or x cube minus 64 a cube is equal to 0. That implies x is 4a. So here x is 0 and x is equal to 4a. Now if x is 0, y will be also equal to 0 here. So substituting x equal to 0 in this, and if x is equal to 4a, we can see that y is also 4a. So it is 4a comma 4a. So the points of intersection are the two curves are intersecting at 0 comma 0 and 4a comma 4a are the points of intersection. After finding points of intersection, so either keep the x as constant and y as a variable, or take y as the constant and x as a variable. So here I am going to take x as the constant. So x from the point in the bounded region, the x varies from 0 to 4a. So this is the point 4a comma 0. X varies from 0 to 4a. So if you take x as a constant, take a vertical strip here. So PQ. The vertical strip, on the vertical strip, find the value of y, because here we are going to consider y as a variable. So the y on the point P is given by x square by 4a, and the y on Q is given by root of 4ax. So y here x will vary from 0 to 4a in the bounded region, and y varies from x square by 4a to it is root of 4x, which will be ax. You can also write the same thing by taking y as a constant and an horizontal strip here. So area is equal to 0 to 4a and x square by 4a to 2 root of ax. Here once you are taken the variables as x, so they are the values of y. So integration will be first with respect to y and then with respect to x. So on integrating, the integration of dy is y. It is 2 root of ax and here it is x square by 4a dx. Put the limits 0 to a 2 root of ax minus x square by 4a dx. Now integrating with respect to x, 2 root a is the constant. Integration of root x is x raised to 3 by 2 by 3 by 2. So the limits of x are from 0 to 4a minus 1 by 4a is the constant. It is x cube by 3 from 0 to 4a. So it is 4 by 3 root a, 4a raised to 3 by 2 minus 1 by 12a, 4a cube raised to cube. On simplifying this, it is 32a square, 32 by 3a square minus 16 by 3a square, which will be 16 by 3a square. Since it is the area, so let me take the units as square units. So they can also give it like find the area between the parabolas y square is equal to x and x square equal to y. So it is the same problem. In this case, the 4a is equal to 1. So that means that the point of intersection, when you substitute the second equation in the first, it will be x raised to 4 is equal to x. So that implies x cube minus x is equal to 0. X cube minus 1 equal to 0. X will be 0 or x is equal to 1. So the point of intersection becomes 0, 0 and 1, 1. So the area we can calculate by taking x variations from 0 to 1. So here the point of intersection is 1, 1 and this is the parabola y square is equal to x and here this is the parabola x square is equal to y. So we can find the limits as 0 to 1, x varies from 0 to 1 and y varies from x square to root x dy dx. On simplifying this, the area is equal to 16 by 3 square units. Thank you for watching.